Hi everybody, this lesson is about quadratic equations. A quadratic equation is an equation in the form ax squared plus bx plus c equal 0, a being not equal to 0. A quadratic equation may have in the real field two solutions or roots, one solution or root, or no solutions or roots. We'll go into more detail in later lessons. Either coefficient b or c, or both of them, may equal 0. Let's now examine 7 equations and find out which of them are quadratic equations. 3x squared plus 4x plus 5 equals 0 is a quadratic equation. In this case, a equals 3, b equals 4, and c equals 5. 3x squared plus 4x minus 5 equals 0 is another quadratic equation. A is 3, b is 4, and c is negative 5. 3x cubed plus 4x plus 5 equals 0 is not a quadratic equation, because 3 multiplies x cubed. 3x squared plus 5 equals 0 is a quadratic equation. In this case, a is 3, b is 0, and c is 5. 3x squared plus 5x equals 0 is a quadratic equation. A is 3, b is 5, and c is 0. 3x equals 0 is not a quadratic equation. 0x squared plus 5x equals 0 is not a quadratic equation, because x squared is multiplied by 0, and we know that a must be different from 0. Let's now see how to solve a quadratic equation. Let's start with the complete equation 2x squared plus 3x minus 5 is equal to 0. A equals 2, b equals 3, c equals negative 5. To solve this equation, we'll apply the so-called quadratic formula. The formula says that x1 and 2, that is, the two possible roots of the quadratic equation, are equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. The quantity b squared minus 4ac is called the discriminant and is indicated by the Greek letter delta. Let's now solve the equation. x1 and 2, that is, the two roots of the equation, if they exist in the real field, is equal to negative b, which is 3, and so negative 3 plus or minus the square root of b squared, that is to say, 3 squared, which is 9, minus 4 times a, which is 2, multiplied by c, which equals negative 5. All that over 2a, that is to say, 2 times 2. Let's go on calculating. Negative 3 plus or minus the square root of 9 plus 40. Two negative factors give a positive product. All divided by 4. Again, that is equal to negative 3 plus or minus the square root of 49, which is 7, divided by 4. We'll now consider the plus and the minus in turn. Negative 3 plus 7 is equal to 4, and 4/4 is 1. Negative 3 minus 7 is equal to negative 10. Negative 10 divided by 4 is negative 5/2 in simplest terms. In this case, we have come to two real solutions. x1, which is equal to 1, and x2, which is equal to negative 5/2. What do we mean by saying that 1 and negative 5/2 are the roots or solutions of the equation? We mean that by substituting 1 or negative 5/2 for the x in the equation, we obtain an identity. Let's try the first root, that is 1. 2 times 1 squared plus 3 times 1 minus 5 is equal to 0. 2 times 1 is 2, plus 3 times 1, which is 3, minus 5 is equal to 0. Finally, we get 0, which is equal to 0. So 1 is a solution of our quadratic equation. We would come to the same result by substituting negative 5/2 for the x in the equation. Let's now examine a spurious quadratic equation, that is, an equation in which a and b are not equal to 0 and c is 0. In this case, a is 4, b is 1, and c is 0. The spurious equation could be solved exactly like the complete one by applying the quadratic formula. On the other hand, it can be solved in a more simple way, considering that the absence of the third term allows us to factor out x. 4 times x squared plus x is equal to x multiplied by 4x plus 1, which is equal to 0. According to the zero product property, the product of x and 4x plus 1 is 0 if either x or 4x plus 1 or both equals 0. That simply leaves us with a linear equation. 4x plus 1 is equal to 0, whose solution is negative 1/4. One of the two roots of a spurious quadratic equation is always 0. That can be verified by substituting 0 for the x in the equation. The same can be done with negative 1/4. 4 multiplied by negative 1/4 squared minus 1/4 is equal to 4 multiplied by 1/16 minus 1/4. 4 and 16 can both be divided by 4, so we have 1/4 minus 1/4 is equal to 0. Let's now examine the pure quadratic equation, that is the one in which a and c are not equal to 0, while b is 0. The first coefficient a is 4, the second b is 0, and the third c is negative 16. This equation, too, could be solved by applying the quadratic formula. However, there is another far more simple way. 4x squared minus 16 is equal to 0. By moving the free term, also called the constant term negative 16, to the right side, we get 4x squared is equal to 16, which easily simplifies to x squared is equal to 4. Now, we just need to extract the square root of both sides. The square root of x squared is equal to the square root of 4. The absolute value of x is 2, and so x1 and 2 are equal to plus or minus 2. The two solutions are x1, which is equal to 2, and x2, which is equal to negative 2. The two roots have the same absolute value, but opposite signs. Let's now try to substitute the two roots for the x in the equation. 4 multiplied by plus or minus 2 squared minus 16 is equal to 0. 4 times 4 minus 16 is equal to 0. And so 0 is equal to 0. The identity is verified. Finally, let's examine the last case, which is perhaps the simplest, the monomial quadratic equation. In this case, a is not equal to 0, while both b and c are 0. In our example, 4x squared is equal to 0, a is 4, b is equal to c, which is equal to 0. The solution is immediate. By dividing both sides by 4, we get x squared is equal to 0. The double root x1 and 2 is 0. We'll get into more detail in later lessons. I hope I've been of use, and thank you for your attention.